All right, now when we're doing this, we have going to be hanging the masses at three different places, two different masses at three different places. And so first off, let's take a look at what this is measuring. Now, the scales are huge considering the amount of force that we have acting on this, and that's just the nature of what we have here. So as I'm looking at this one right here, I'm going to read this, and the question is, how should I read this particular scale right here? Because I've got a thick bar that's on the scale, and I need to be able to look at it a little bit better than that. So I need to figure out what is at 0. So when I don't have the meter stick acting on the force at all here, that the top of this particular indicator right here is actually halfway between the 0 and the first line below that. And so I need to take that into account. And so it ends up being, see, this is in increments of 25 grams. Now, this is one of those cases where the force scale has grams on it. This assumes that it's being used on Earth. You know, that's their market. However, really, I hate it when they do that, but it's what we're living with. I could do it in ounces and do a conversion, but grams is just going to be easier. Technically, it's not a conversion, but we're doing this anyway. So right now, so I know where that one is. This one over here, I'm going to also do this just to see where this, how this one measures. And on this one, when no force is acting on it, that the top of the bar is where is what I should be measuring. So I'm going to take my 200 gram mass here, and I'm going to put it at the 30 centimeter mark. All right, I've just hooked the 200 centimeter mass there. I now have some force scale readings, and so let's write up what we have here. So I've got my meter stick right here at the 30 centimeter mark. I have a force acting down, and that force is going to be the weight of that mass, which is 0.2 kilograms times 9.8 meters per second squared. I have the force of the meter stick at the 48.7 centimeter mark, and that's going to be 0.10691 times 9.8. And then I have a force acting up here at the 90 centimeter mark. And that is going to be, well, we have to actually read it. So this one was at the top, and that's 0.075 times 9.8. And let me just double check that one. Is that 200? All right. And this one right here should be a half mark above, and this is at 0.2. So I have at the 10 centimeter mark, 0.2 times 9.8. And now let's actually crank through the math. Let's see how close we actually get to what theory says, and that'll be